Yeah, so it's not too much video watching. I'm going to do this one. This is chapter 1, section 6 on the separate sheet. So it's a separate video. That's what I call it, part 2. All right, let's look at these problems. Remember, section 6 dealt with inequalities. We have 6x minus 1 is greater than 4x plus 11. Solve it and put your answers in interval notation. Remember from last week we had 3 different notations. We had the set, interval, and then the graph. The set dealt with inequalities, intervals dealt with brackets and parentheses, and the graphs dealt with open and closed circles. So when we solve inequalities, treat the inequality the same as an equal sign. So this is the same as an equal sign. I have x's on both sides, so I move the smaller x to the larger. Six minus 4 is 2x, is greater than or equal to 11. Add 1 to both sides. That gets rid of that one. 2x, 11 plus 1 is 12. And then divide by 2. So x is greater than 6. That's the answer in set notation. So we have a 6. Because there's no line underneath it, it's an open circle. Whenever you have x on the left-hand side, wherever that arrow is pointing, that's the direction you shade. And it goes from 6 to infinity. So that's graphing. This is set. Now the integral notation, you only take the endpoints. 6 to infinity. Infinity is always parentheses since you can't get to it. And since that's open, you can't use it. And there's that solution. Number 2. X plus 3 is less than 6x minus 17. Again, same thing. Solve it and give me the answer in interval notations. Treat this the same way you do an equal sign. You have x's on both sides. Move the smaller to the larger. There's a 1, so it's a 1x. Subtract 1x from both sides. X's cancel. 6 minus 1 is 5x. Bring down everything else. Get rid of the 17 since we're trying to get x by itself. Remember, whatever you do to one side, you have to do the other side. That's the golden rule. 17 plus 3 is 20. Those cancel. And divide by 5. 5 goes into 24 times. Again, it looks ugly when the right x on the right hand side, so we can move them around. But be careful, that arrow still has to point towards the 4. There's your answer. Starts at 4. It's an open circle, and it's going to the right. It's going to infinity. So the interval notation for an infinity, open is the parenthesis. Alright, let's look at another one. I'm sorry, if I went too fast there, just pause it and look at it again. Sorry. Now the next one, 11 minus 2x is less than equal to 4x plus 23. Treat this the same way you do an equal sign. You have two x's. Move the smaller to the larger. Negative 2 is smaller than 4. So we have to add 2x to both sides. Those two x's cancel, so it's 11 is less than equal to 4 plus 2 is 6 plus 23. Bring down everything else. Now I have to get rid of the 23. It's a positive, so we subtract it. Subtract 23 from both sides. So there's 6x on the right hand side. 23 is bigger than 11, so the answer is negative. 23 minus 11. 3 minus 1 is 2. 2 minus 1 is 12. Divide by 6. Right, the x is still positive, so we don't have to flip anything else. So there's x on that side. Negative 12 divided by 6 is 2. Okay, I'm going to flip them. So it still has to point to the negative 2. There's your set notation. Since it has an equal sign, it's a closed graph pointing to the right, so it goes that way. So the interval notation is from negative 2 to infinity, but that's closed, so we have a bracket. That line there matches that line there. Now let's look at some fractions. Negative 3 over 4x is greater than or equal to negative 7 over 12 plus 2 over 3x. Remember, treat that same as an equal, so we have equal sign in fractions, LCD. The smallest number that all three of these fit into is 12. So multiply the LCD to each term. Put this one in parentheses. Negative 3 over 4x greater than or equal to. Put a 12. Put this in parentheses. Negative 7 over 12 plus your LCD and then everything else behind it. 2 over 3x. Reduce to get rid of the parentheses, the fractions. 4 goes into 12 3 times. 12 goes into 12 once. 3 goes into 12 4 times. This is what we have now. 1 times negative 7, 4 times 2x. No more fractions, so let's multiply to get rid of the fraction, the parentheses, sorry. So positive times negative is negative. 3 times 3 is 9x. Positive times negative is negative. 1 times 7 is 7. Positive times positive is positive. 4 times 2 is 8x. Okay, we have x's on both sides. Move the smaller to the larger. Negative 9 is smaller than 8. The sign goes with the number. So I have to add 9 to both sides, a 9x. Those cancel. Negative 9 plus 9 is 0. There's negative 7. 8 plus 9 is 17. X. Get rid of the 7, since I only want x's on this side. So 7 is greater than or equal to 17x. Now come over here. 7 is greater than or equal to 17x. Divide both sides by 17. 7 over 17 is greater than or equal to x. Flip them around. Now this side, this time is pointing towards the x with an equal sign. So there's the set notation. We have 7 over 17. It's a solid circle, and it's going to the left now. This way it goes to negative infinity. So our set notation is from negative infinity to 7 over 17. Infinity is always a parenthesis. Since it's an equal sign or a solid dot, it's a bracket. Number 5. Y equals square root of x minus 4. Find the domain in interval notation. All right, again, this is the reason I asked y'all to memorize those tables and charts, those graphs, that sheet I gave you. What do we know about the square root? What do we know about that basic function? The graph of this function looks like this. Notice what this set tells us is you cannot have any negatives inside there. The smallest you can have is 0. And then it goes to infinity. Positive infinity. So the smallest number you can have inside here is 0. So what would x have to be to make it 0? Solve for x. So when x equals 4, inside here is 0. That's the smallest it can go. So in our graph, it would look something like this. Because if I put 5 in there, 5 minus 4 is 1. Square root of 1 is 1. How about this one? 8 minus 4 is 4. Square root of 4 is 2. So we see here it goes all the way to infinity. So from 4 to infinity, but we can use 4. So there it is in interval notation. In set notation, This is typically how you always write it, because I want to know what x equals. So looking at this, x is greater than or equal to 4. You start off with 4. Which way is the graph going? To the right. And it can equal. So there's your set notation. Number 6. Negative 4 less than 2x plus 1 is less than 5. Solve and give me your answer in interval notation. Now this is a 3-part question. It's a tripartite. But we're only interested in x. So whatever we do here, that's the important thing. We'll do it to the other sides. So we have to get x by itself, so we subtract 1 from everybody. 1 minus 1 cancels. Both negatives. 4 plus 1 is 5. Less than 2x. 5 minus 1 is 4. Try to get x by itself, so I divide by 2. Those cancel. Negative 5 over 2 is less than x. 4 divided by 2 is 2. There it is in set notation. In interval notation, just use the endpoints. Negative 5 over 2, comma 2. Since these are both just regular, there's no lines underneath them, so there's your answer. It's just parentheses. All right, number 7. Negative 2 is less than 4 minus 2x negative 4. 4 minus 2x less than equal to 12. Again, we're only interested inside where the x is, so whatever we do here, we'll do to the other two sides. Get rid of the 4 first. Since it's a positive 4, we have to subtract 4. They're both negative. The answer is negative. 4 plus 2 is 6. Less than. The 4's cancel. Negative 2x. Less than equal to 12 minus 4. 12 is bigger, so it's positive. 12 minus 4 is 8. Negative sign. So change everything. Change the sign of the first one, change the direction, change the sign from x, change the second one, and change the sign of 8. So it becomes a positive 6. That one switches the direction. That becomes a positive 2x, switches direction. And that one becomes a negative 8. So you see, when we just change the signs, everything just changes directions and changes everything. But we don't want negatives on the right, positives on the left. So let's just move this one. We want this one over here. The 2x stays in the middle, and this one put over here. It has to point to the negative 8. And it has to point to the 2. So between the 6 and the 2 has to point to the 2. Between the 8 and the 2 has to point to the 8. Now we just divide by 2. Half of negative 8 is negative 4, less than x. 6 divided by 2 is 3. Oops. Less than equal to. Don't forget that. So there you have the answer in set notation. In interval notation, it would be -4, comma 3. Go to the endpoints. This one has nothing, so it's not included. This one's an equal sign, so it's included. Let's look at one with fractions. -1 is less than 1/4. 2m plus 2 less than equal to 16. Okay. You treat these the same way you do equal signs, and we have a fraction. So what's the LCD? Well, it's the only fraction we have, so it's 4. Multiply the LCD to every term. So here's the first term. So it's 4 times -1 is less than 4 times 1/4 2m plus 2 less than equal to 4 times 16. Third step, reduce. The only place we reduce is here. 4 times -1 is less than 1 times 1 times 2m plus 2. This had parentheses around it already. When I put the outer parentheses, put the LCD, you'll have 2 at the end and 2 in front. 4 times 16 is 64. Multiply to get rid of the parentheses. Positive and negative is negative. 4 times 1 is 4. 1 times 1 is 1, so there's nothing. So there's nothing in front of this. 1 times 1 is 1, so nothing changes inside there. Because 1 times everything here is just itself. And then 64. The last step is solve. We're trying to get the m by itself, so subtract 2. Those cancel, so negative is a negative. 4 plus 2 is 6. Less than equal to 64 minus 2 is 62. So because you're subtracting, that's where we keep the signs. If you were multiplying, if it was -4 times -2, negative would cancel, you'll get a +8. But here we're adding and subtracting, same signs. Keep the sign, add the numbers. Divide by 2, those cancel. -6 divided by 2 is 3. M less than equal to 2 goes into 6 3 times, 2 goes into 2 once. So our endpoints are -3, 31. This one doesn't have anything, so it's a parenthesis. This one has a line, so it's a bracket. The graph would be open circle, close circle, and X is between there. All right. Last one from this section. This will close out chapter 1. It's a word problem. You're going to move. You're going to move. So you compare two movers. Acme and Hanks. Acme Movers charges a flat fee of $100 plus $30 per hour. Hanks Movers charges $55 per hour. How many hours would make Hanks Movers lower cost than Acme? So how many hours would make Hanks Movers, because eventually at some point they could come out to be equal. So what we're looking for is this. Hank is less than Acme. What's Hank's formula? Hank's is $55 per hour. So it's 55, let's call X the number of hours. Acme starts off with $100 plus $30 for every hour. Let's see at what point, up to what point Hanks is cheaper. Solve for X. Subtract 30x from both sides. 5 minus 3 is 2. 5 minus 0 is 0. It's 5. So 25x is less than 100. Divide by 25. Those cancel. X is less than 100 divided by 25 is 4. So anything less than 4 hours. So from 0 up to 4 hours, Hanks. After 4 hours, it'd be cheaper to use. So if your job takes less than 4 hours, use Hanks. If it's greater than 4 hours, use Acme. All right, so that's section 1.6. That does it for chapter 1. Good luck.